For over 50 years, no one on Earth could see what existed on the other side of the moon. This hidden place, which always faces away from us, held secrets that left NASA scientists speechless when they finally managed to photograph it. What seemed to be just normal rocks and craters ended up revealing very strange things. Giant craters the size of entire countries, mysterious marks that shouldn't be there, and a surface completely different from the side we see from Earth. Astronauts who flew around the moon reported strange sounds on their radios when passing through the dark side, sounds that NASA took decades to explain. But the most shocking came from more recent missions. Instruments detected things buried beneath the surface that don't make sense, enormous metal structures weighing billions of tons. This forced scientists to ask a frightening question. What really happened on the dark side of the moon that left these impossible marks? Subscribe to the channel, leave your like and comment from which part of the world you're watching, get comfortable and relax. Let's begin. What is really on the side of the moon that we cannot see from Earth? This question is simple, but for hundreds of years, it has made people wonder and dream. When you look at the moon in the sky, you always see the same face. If you stare at it every night for many months, it does not change. The same round spots, the same shapes, and the same gray color meet your eyes. But what about the other side, the part that never turns to look at us? For a very long time, no one on Earth knew the answer. The moon circles our planet, but it does something special. As it moves around Earth, it also turns at the same speed. This means that one side is always facing us, and the other side is always turned away. This way of turning is called tidal locking. It keeps half of the moon's face hidden, like a secret that the sky does not want to share. People soon gave the far side a name. Some called it the dark side, not because it gets no sunlight, but because it is always out of sight. The word dark here means hidden, not without light. For many hundreds of years, people only knew the side of the moon they could see. Even early scientists who tried to study the moon with small telescopes could not look around to the hidden face. Back then, building very strong telescopes or sending anything to space was impossible. The far side stayed covered in mystery, and that made everyone even more curious. Writers and artists began to imagine what might be there. Some wrote stories about strange animals or even people living just out of sight. Some thought the moon might have its own secrets or treasures hiding where no one could look. Over time, as people started to learn more about the sky, they wanted answers. They could see the bright spots on the side facing us. These lighter places are called the highlands. There are also darker, flat patches that look almost like seas. These are called the Maria, a word that comes from Latin and means seas. Through small telescopes, people could count round holes called craters, made when space rocks hit the moon, but nothing could show them the other side. It was as if the far side was a closed book, its pages stuck together. Origin stories grew. Some said the moon kept its side hidden because it had something to protect. Others joked that there must be a reason only one side smiled at Earth. No matter what people believed, they all agreed on one thing. The far side was the moon's greatest mystery. No explorer with a ship or a wagon, no bird or balloon could ever travel there. It was simply not possible. As time passed, science moved forward. People began to understand how gravity works and how things move in space. They watched the moon's journey across the sky and learned that it takes about 27 days and 8 hours to go all the way around Earth. The moon also takes just as long to turn once on its own axis. That is why we always see the same side, because the two movements match each other so closely. Even though people learned these things, the far side of the moon stayed secret. Nothing on Earth could shine a light there. No hand could touch it. Stories continued. Some people who liked to dream said there might be towers, cities, or vast machines hidden from our eyes. Some thought the far side might look just like the one we see, or maybe it was different. Others made up poems and songs about what is out of sight. Nobody knew the truth, and the mystery just grew. By the time the first big telescopes were built in the 1900s, scientists could see small details on the side facing Earth. They could count even tiny craters and draw careful maps. But no matter how good the machines were, the far side always stayed hidden. People tried to guess what they would find. Some hoped it would be full of flat places, and others thought it would be even rougher and full of holes. The truth was, all anyone could do was guess. As people watched the moon, some noticed another strange thing. Very small changes happen when the moon moves, which means that if you watch very closely, you can see a little more than just half of it. This is called libration. Because of this small wobble, about 59% of the moon can be seen from Earth, but never all at once. Still, the rest, the true far side, remains covered, locked away from human eyes. For a long time, stories of the hidden side were only dreams and drawings. The far side became a stage for adventure in books and in the minds of children. People from different lands made up their own tales. In some places, old legends spoke of magic or gods living on the moon. In others, the far side was a land of endless night. Many people thought someday someone would discover what was really there. When the first scientists became interested in space, they wondered if the other side was different. Did its land have big mountains? Was the ground smooth or full of holes? Nobody could say for sure. Early maps of the moon had a blank space on the far side, just a white area with no names or shapes. Even as men and women learned more about planets and stars, the far side stayed a mystery. In the 1800s, some novelists wrote about traveling around the moon. Their stories showed brave explorers in strange ships, circling to see the hidden face. Others wrote about what they thought was on the other side, cities made of crystal or forests under silver light. These stories were not true, but they made people wonder even more. The lack of real answers made imagination grow bigger and bigger. By the middle of the 20th century, technology began to change everything. People dreamed of flying into space, and some leaders in different countries wanted to reach the moon one day. But even as rockets and big machines were being built, no one could still peek behind the moon. It stayed the only place near Earth where everything was a guess. Children in many places grew up looking at the moon, thinking about what could be on the other side. Some children asked their parents if there were animals or people living there. Some tried to draw what they imagined with trees, rivers, or even whole cities. Adults, too, sometimes looked up and tried to picture the far side as they walked at night. The moon's far side was not just a puzzle for science, it was a place of dreams for everyone. By now, the moon's story was part of human life. Its far side had become a symbol of the unknown, a place that no one had ever seen. Great thinkers said that there are always things in life we cannot see but are still curious about. The hidden side of the moon showed that even with all our power and learning, there are still secrets waiting for us. Every night, as the moon rose, it reminded people of the mysteries that might be just out of sight. Many people also became curious about how the moon affects Earth. The moon pulls on our oceans to make tides, and its light has helped people travel at night for many thousands of years. People wondered if the hidden side might play a special role in these things too. Was there something about the moon's far side that changed the way it moves, or how it looks from space? Again, nobody knew for sure. The far side remained a challenge for humans. When people learned to send radio waves long distances and use better telescopes, they still could not look all the way around the moon. The hidden face stayed quiet, never sending a signal. never showing its shape. Our closest neighbor in space kept its most important secret very well. All of this waiting made discovering the truth about the moon's far side more important than ever. In the minds of scientists, writers, and everyday people, it became one of the oldest puzzles in the sky. There was no way to send a message around the moon, and no camera could take a picture from behind it. If anyone wanted to solve the mystery, they would need to go into space themselves. By the late 1950s, the world was changing quickly. Countries around the world began to work on sending machines beyond our planet. The dream of reaching the moon was becoming real. But for all these years, the story of the moon's far side stayed the same, a place no human or machine had ever seen. People kept looking up at the moon every night, knowing that over half of its surface was still waiting to be discovered. The hidden face was like a locked door in the night sky. Behind it, everyone hoped, were new answers and maybe even new questions. Scientists began to build new plans and new machines that could one day show the world what had always been hidden. And so, the mystery of the moon's far side continued, strong as ever, holding tight to its secrets. Many people waited a very long time for even the first clue about what truly existed on the far side of the moon. While their curiosity grew, a new period in history began. This was an age where humans tried to send objects into space. Scientists and engineers in several countries started to think about building machines that could travel beyond Earth. The idea of flying to the moon and going far enough to look behind it was not just a dream anymore, but something that could one day happen with enough work and learning. During the middle of the 20th century, people made many discoveries about rockets and ways to send things past our sky. Groups of scientists came together. They planned ways to build machines not for people, but for traveling as far as the moon. They hoped these machines could carry cameras or sensors to help discover new information. At first, many things went wrong. Some rockets did not fly high enough. Others broke apart or fell back to the ground. But each lesson helped. With every new test, teams fixed problems and learned more. In the year 1957, a big step was taken. The Soviet Union, a large country at that time, sent a small, round machine called Sputnik into space. It circled around Earth again and again. People all over the world listened to the beeps it sent back. This simple sound showed it was possible to send things where no human had ever reached. Once everyone saw this was possible, interest in reaching the moon grew very quickly. Scientists and leaders in the United States began to work harder. They wanted to send their own machines into space, and they also dreamed of seeing the far side of the moon for the first time. The mystery that waited on the moon's hidden face pushed these people to work faster and smarter. Teams built rockets that were stronger and safer than ever before. Not long after Sputnik flew, the Soviet Union tried to send a spacecraft toward the moon. Their first tries failed, but by the end of the year 1959, something special happened. A spacecraft named Luna 3 was sent to circle around the moon. Luna 3 was not very big. It did not carry people, but it had something important inside, a simple camera that could take pictures and a way to send the pictures back to Earth. Luna 3's journey was not easy. It left Earth and traveled for many hours, following a path that was planned very carefully. When it reached the far side of the moon, it turned its camera out of a small window and took many photos. For the first time since people started looking at the sky, someone or something was finally looking at the side of the moon that could not be seen from Earth. The pictures that Luna 3 sent back were not perfect. The technology was still new, and sometimes the pictures were blurry and the light was not always the best. Still, these images showed things that no person had ever seen. When the first photos arrived, scientists were surprised. The far side surface looked very different. The places that could be seen in the Luna 3 images were covered in marks, round craters, and places that were not seen on the side facing Earth. People all around the world waited for the photos. When some were shown in newspapers and on television, everyone was excited. Even though the pictures were simple, they proved that the far side of the moon had real shapes and features, not just empty space or someone's dream. There were high spots and valleys. The ground seemed rough and shaped by time. The mystery was not finished, but for the first time, there was a real look at a place that had been a secret for so many years. These first images made scientists ask new questions. Why did the far side look so different from the near side? Why did it have so many more holes and craters? Why were the big flat areas called Maria missing on the far side? Each picture opened a door to many more questions. The hidden half of the moon was no longer just a blank space on maps. Now there was proof that it was full of strange and interesting things to study. The United States and the Soviet Union both wanted to explore more. They each sent more spacecraft to the moon. Every new mission tried to do something that had not been done before. Some craft circled the moon, while others crashed on purpose to test the ground. Some even tried to land softly, which was very hard to do with the simple computers and weak engines of that time. Each new journey to the moon taught people something different. One spacecraft showed that the moon's gravity was not the same everywhere. Another took clearer photos, showing even more craters and strange shapes. Some measured the temperature or the amount of light coming from the moon's surface. All this new information helped scientists on Earth understand the moon better, little by little. With each mission, the technology improved. New systems allowed spacecraft to send back more and better pictures. Scientists learned how to plan their paths very closely so they could send a machine exactly where they wanted. The images of the far side got less blurry and more details could be seen. The early years of space travel were full of mistakes and simple machines, but soon people were able to see sharp, clear views of the far side. People working at NASA in the United States spent many nights looking at each new picture. They could now find places to land future spacecraft and even imagine sending people one day. Small craters, big mountains, and long ridges on the far side started to get names. Scientists shared these names with others around the world, and maps of the far side became full of features. The wonder of the far side did not only belong to scientists. People everywhere looked at newspapers and televisions, waiting to see a new image or learn something new. The public excitement gave new energy to the space programs. Young students in school dreamed of working in space science, and some even made small models of spaceships and the moon to play with. Many people talked about the far side as a new world, even though it was very close to home. During these years, the United States began a set of special missions called the Lunar Orbiter Program. These spacecraft were sent to circle the moon over and over, taking thousands of pictures of both the side we see and the far side. These sets of photographs showed the far side in great detail. Now people could see cliffs, chains of craters, and signs of old collisions from space rocks. Some features were large and could be seen from far away. Others were tiny with details that amazed everyone who saw them. The Soviet Union and other countries sent their own missions to study the moon. Each time, their machines added to the knowledge and understanding of what was on the far side. As more pictures were collected, experts saw that the far side was even stranger than anyone first thought. They began to see lines, strange shapes, and patterns that could not be explained by the normal ways craters usually form. This wave of discoveries showed something unexpected. The two sides of the moon were not the same. The side that faces Earth has many smooth seas and fewer big craters. The far side has almost no Maria, but it is full of old marks and deep holes. Some areas look broken and rough, as if they were shaped by great impacts from long ago. These facts made people wonder even more about why the moon had formed in this strange way. As the pictures kept coming, scientists realized that the far side of the moon had been untouched and unseen for billions of years. It had not changed very much since the time when the moon was young. Because no one from Earth could see or reach it, the far side stayed safe from the effects of sunlight, changes in temperature, or even rocks that sometimes hit the near side. More missions followed. The United States sent a series of probes called Ranger and then Surveyor. These machines gave detailed information about the moon's rocks and dust. They helped NASA get ready for the bigger mission that everyone hoped for, sending humans to land on the moon and explore it in person. Each mission was hard work. Every step required new ideas and patience. Sometimes rockets exploded or got lost. Sometimes pictures were ruined by too much light or not enough. But every time teams had a problem, they tried hard to solve it and try again. The dreams of seeing the moon, all of it, both sides, was too important to give up. During these years, television and radio kept people everywhere excited. People sat with families and friends, waiting for any news about the next spacecraft or pictures coming from the moon. Stories filled newspapers and magazines. Some people felt proud that humans could now look at a place that had been a secret for so long. Others wondered how much more there was left to find. Most scientists quickly agreed on one thing: the far side of the moon was worth looking at much more. Each bit of information led to bigger questions. If the far side looked so different, could the inside of the moon also be different on that side? Was there something under the ground that made it strange? Did other planets have one face that was hidden too? These new mysteries made space science very exciting for people everywhere. Over the years, as technology kept getting better, more spacecraft were sent with cameras, sensors, and even ways to scan below the surface. The data sent back from these machines was collected, checked, and studied by teams all over the world. They shared what they learned and worked together to create even better maps of the moon. The far side now had a true face for the first time in history. The excitement of these discoveries changed how people felt about space exploration. More countries joined in, sending their own missions to the moon and other places. The secrets that the moon had held for so long were finally being uncovered, piece by piece. Yet, if anything, the new information made people even more curious. Now that they could see the far side, they wanted to know what made it so different and how it was shaped by time. As spacecraft circled the moon again and again, it became possible to take thousands of pictures from every angle. The far side's craters, cracks, and marks could be looked at closely. Some scientists started to wonder if they were seeing things made by impacts or maybe something else. They noticed patterns that did not look like normal craters. Some marks were long lines instead of round shapes. Some were circles that seemed out of place. There was still much to study, and even with all the new technology, not every answer was clear. The big question that began all these missions, what is really on the side of the moon that we cannot see, was now partly answered. People had pictures, maps, and lots of new data. The far side was real, full of strange shapes, deep holes, and ancient marks. But each new answer showed something else to learn. Now that the far side was no longer just a mystery, scientists decided to focus on why its surface was so different. They wondered how all the craters were made, why there were almost no Maria, and what the patterns meant. Every photo, every bit of rock and dust measured, brought people closer to new questions. The moon's far side, once only a story and a dream, had become the next puzzle for science to solve. The images and measurements from the first missions showed that the far side of the moon was not just a hidden place, but a surface full of surprises. When scientists studied the new photographs, they began to notice very special things about the side that never faces Earth. The ground there did not look the same at all. The questions became bigger and more detailed because what was discovered went beyond just seeing new land. It was not only about finally looking at the far side, but about understanding why it was so different from the side everyone sees from Earth. When the first close-up pictures came through the radio signals, many experts gathered to look at them. They had expected to find some craters because space rocks hit all sides of the moon. But what surprised them was how many there were. The far side showed a large number of craters, much more than could be seen on the side people watch from the ground at night. Some areas on the far side were full of holes of all shapes and sizes, covering almost every place in the pictures. On the near side, the one that faces Earth, there are wide, dark, smooth spaces. These are called Maria, which means seas. They are not made of water. Instead, they are great plains of frozen lava from volcanoes that were active a long time ago. On the far side, these wide, flat places were almost missing. Only a few small Maria could be found, and they were nothing like the large, open areas on the near side. This was strange because people thought the moon would have similar parts on both faces. Many of the craters on the far side were also much larger and deeper than most of those on the near side. Some of them were so big that scientists had trouble measuring how wide or deep they really stretched. The ground often looked rough and very old, almost as if it had been left alone for a much longer time. Scores of smaller craters filled the spaces between the bigger ones, creating a surface that was never smooth or flat. Scientists began to count the craters and study how they were arranged. They wanted to know why so many space rocks had hit the far side, or if some other force had worked only on that part of the moon. The patterns did not match what was found on the side that faces Earth. Teams made maps of the big holes and their shapes. The more they searched, the clearer it was that the far side had lived a very different story. There were also unusual marks that did not look like simple craters. Instead of being round, some were long, narrow, or broken. There were lines in the ground like shallow scratches that stretched for many kilometers. Some of these lines seemed to cross over each other, meeting in ways that scientists could not explain right away. These strange marks added more mystery to the surface, as if something unusual had happened in the past. Another thing that surprised scientists was the color of the surface. It was more pale in most places than the side that faces Earth. The rocks and the ground there seemed richer in certain kinds of minerals that are light in color. This helped them know that the far side was made up from different things than the near side. Tests showed that the ground there was more like the highlands on the side facing Earth, and not like the smooth, dark Maria Plains. With all these differences, scientists wanted to know how the two sides could become so unlike each other. They studied how meteors fly through space, thinking maybe more rocks crash into the far side. But their work showed that the number of space rocks hitting both sides should be almost the same. Since the moon turns only once every trip around Earth, every side faces space in nearly the same way as time goes by. So it was not just more impacts causing the strange surface. Ideas grew that maybe something happened a very long time ago, when the moon was still being formed. Some experts suggested that the near side cooled in a special way, letting large pools of lava flow out and make the Maria, while the far side cooled faster, never letting wide plains form. Others thought a very large space rock could have hit the moon from one direction and pushed heavier parts of it toward one side. Still, no answer was easy or simple, and each idea brought its own new questions. The mystery became even more interesting when scientists measured how thick the moon's crust is. They found that the crust on the far side of the moon is thicker than the one on the near side. This difference was important because the thick crust on the far side made it hard for lava to come out and cover the ground. Since lava could not easily reach the surface, almost no Maria plains formed on that half. Instead, the crust held on to the old shape, keeping records of billions of years of impacts in its rough ground. Some scientists built computer models to study how heat and energy changed inside the moon after it formed. These models showed that the far side may have cooled much quicker, staying hard and rough, while the near side was warmer for longer. The warmth could have helped molten rock escape more often on the near side, making the large, smooth Maria. These ideas matched with some of the pictures and data, but not with everything. There were still pieces missing from the story. Even with better pictures and many missions, some marks on the far side shocked experts. In some places, the ground looked almost shattered, filled with thin, deep break lines stretching in many directions. These features did not look like regular cracks or like marks from simple impacts. The lines were too long, with some winding for many hundreds of kilometers. Sometimes they were grouped together, running almost in the same direction, as if something moved below the surface a very long time ago. There were also strange circular shapes too big and too smooth to be ordinary craters. Some of these circles covered huge ground areas, and their edges were gentle hills, not sharp, blown-out walls like normal impacts. Scientists wondered if these were made by giant objects hitting the moon billions of years ago, or if slow movement inside the moon could push the land up and make these shapes. Some marks were so odd that scientists did not even have names for them when they first saw them. The more the far side was studied, the more it became clear that no other place close to Earth was quite like it. Every detail, every unexpected pattern made people want to keep looking for answers. There were mysteries in the number of craters, mysteries in the lines and circles, and even mysteries in the types of rocks and dust found on the far side. Looking at pictures sent back by new spacecraft, teams of scientists kept finding signs that the far side had a long history full of dramatic events. Older impacts had left scars that could still be seen, while new ones added fresh holes on top. The ground was a record of billions of years, but there were gaps in the record that nobody could explain by looking at impacts alone. In the data, scientists spotted one place that stood out from everything else. This area was called the South Pole Aitken Basin. It is a giant basin, so wide and deep that it almost seems to be a world by itself. It reaches across close to 2,500 kilometers and is more than 8 kilometers deep in some places. It may be one of the oldest and largest impact features in the solar system. This basin was created by something very powerful hitting the moon a long time ago, digging deep into the crust and changing the land forever. When the South Pole Aitken Basin was first studied, scientists realized that its floor held rocks from deep below the moon's surface. This was important because looking at these rocks could give clues about what the moon was like in its early days. The basin also explained why some areas around it looked different from the rest of the far side. Over millions of years, rocks and dust from the impact spread far and wide, shaping the surface for a long time. Even small details were strange. For example, on the far side, some craters seemed to be stacked on top of each other, as if impacts came in many waves over and over again. At the same time, other places had craters that looked very fresh, with sharp edges and bright material on their rims. These features told scientists that the far side is still being changed by new impacts. just like the side that faces Earth. Looking at the ground for clues, teams analyzed the shape of the shadows and found tiny bumps and pits, marking places where the moon's crust may have broken or bent under pressure. In places, odd hills rise from the surface with no clear cause. Scientists looked for patterns, hoping to find a rule that explained how the land was shaped, but there were too many questions left. Another mystery grew as new data arrived. The far side often reflected light in ways that were hard to explain. Some ground was very shiny under certain kinds of sunlight, while other places were dull, almost as if they were covered in something soft and different. When special cameras looked for heat, they found places that stayed hotter or colder than normal. These strange markings suggested that some parts of the ground were made from different rocks, or perhaps covered by materials never seen close up. Samples from robotic landers and later from human missions showed that the soil on the far side had less of some minerals found on the near side. In particular, the far side had much less iron and titanium. The rocks there showed very little of the kind of volcanic material that fills the Maria on the near side. Instead, most of the far side was made from old, hard, light-colored rocks called anorthosite. These rocks are very old, some dating back more than 4 billion years. These findings made scientists believe that the far side is more like the earliest moon, unchanged by much of the lava that flowed later. But even this idea had problems. No simple answer could fit everything seen in the pictures, in the samples, and in the computer models. New theories appeared to try to explain why the two sides are so different. Some suggested that Earth's gravity pulled more heat toward the near side, keeping it warm longer. Others thought a giant object hit the far side long ago, thickening the crust and making Maria formation nearly impossible. Still, others wondered if the moon formed in two main pieces that joined only at the end, leaving a split like what people see today. As spacecraft with better tools kept sending back photos and measurements, the strange patterns on the far side became even clearer. Some marks appeared as faint ridges and scarps, lines where the surface has broken and slid from very slow changes inside the moon. Sometimes these lines stretched for hundreds of kilometers, passing through old craters and even over hills. Because the far side remains out of view from Earth, it has been protected from human influence and most radio waves. This has allowed scientists to use it as a natural quiet zone to study space and the sun. Some missions have even dragged long antennas behind their landers, listening to the sky without interference from human-made signals. Much of what has been learned about the far side has come from patience and small steps. Every mission has brought back a little more information. Each new photo or reading has added to the mystery and excitement. As technology improved, it became possible to study even smaller shapes, fainter shadows, and subtler changes in color and heat. Although science has found out much about the surface of the moon, the story was not finished. The rough, old face of the far side still hides many secrets, especially under its ground. Ideas began to spread that there were even stranger things waiting below the craters and rocks. The next step was to try to look under the surface, using new instruments and stronger machines. While the patterns seen from above were special, what lay beneath could be even more surprising. Scientists prepared for new missions to help unlock the deep past of the moon, with hopes of finding even more about why the far side is so different. While much attention was given to how the far side of the moon was full of craters and rough ground, scientists began to notice that the shapes they saw did not all appear in normal ways. Looking at more and more photographs sent by spacecraft, patterns became clear. There were marks on the far side of the moon that were not like simple circles or holes left by falling space rocks. These new shapes stood out as unusual. Researchers wanted to know what made these features and what stories they might tell about the moon's history. In some places, they saw very long lines that did not stop for many kilometers. These lines sometimes cut across old craters, hills, and empty spaces. Some lines were deep grooves, wide enough for shadows to show in every picture. When checking maps, scientists found that a few of these lines ran almost straight from one end to another. Other lines curved and bent, going across the land in soft arcs or sharp turns. The longest of these lines sometimes lasted for hundreds of kilometers, starting at the edge of great basins and continuing deep into the moon's far side. There were also narrow marks called rills. These looked like very thin channels or ditches lying on the surface. They wound through fields of dust, sometimes joining together or ending at the foot of mountains. Some rills were so tiny that they could only be seen in the best photographs. In some cases, they ran side by side, almost as if they had been made all at the same time. Researchers could not find a simple rule for their shape or direction. Some ran in groups, others alone. Some stopped in the middle of nowhere, while others connected to big holes or cracked ground. Another type of formation was the chain of craters. Instead of just one hole, these chains appeared as small circles linked together in a long row. Some chains followed a straight line, while others went in broken paths. The first links in a chain were often bigger, while the last ones might be only slight dips in the ground. Scientists used special maps to trace these chains, sometimes finding that they connected two large craters or crossed ridges and old mountains. The cause for these crater chains was not always clear. Most thought they may have come from strings of space rocks breaking up before hitting the surface, but not every chain fit this idea. Circular marks puzzled researchers in other ways. While many craters are round from impacts, some circles seem too perfect and too big to be simple impact holes. Around the South Pole Aitken Basin, scientists saw very soft circles with edges that rose and fell gently, not like the sharp walls of normal craters. Some circles lay on top of straight lines and grooves, looking like they had formed after cracks or movements under the ground. These formations made people wonder if there could be slow changes happening below the surface, even after the big impact stopped. Stranger still were patterns that did not look like any known formation. On a few parts of the far side, lines, curves, and dots joined together to form shapes with no clear meaning. Sometimes these would look like broken rings, strings of dots, or small zigzags. No two of these patterns matched each other exactly. Scientists marked these places on maps and gave numbers to the oddest shapes, hoping that with time they could learn more about what made them. Beside the lines and circles, some areas of the far side had sharp drops in the ground called faults. These were places where the land looked as if it had been pushed or pulled until it broke, making one side lower than the other. The edges of these faults could be steep, sometimes running for tens of kilometers. Some faults lined up with the grooves and long lines, making it hard to tell where one feature ended and another began. At times, the land on one side of a fault would be covered with new craters, while the other side would be older, showing that the breaking had happened at different moments in the moon's long history. The far side also held high ridges, some running straight and others twisting in curves. These ridges could be seen from orbit, stretching like waves from the center of big basins. Many maps of the far side showed tall ridges that ran together to make chains, marking the places where ancient impacts may have pushed land up on the edges of giant holes. Some ridges were covered in small craters, while others showed smooth, bright rock where the ground had broken cleanly. Looking closely at the ground, scientists found places where materials seemed mixed up. Fields of small boulders, dust, and chunks of rock covered broad areas with no clear pattern. Sometimes the shapes made by scattered debris looked like lines or curves from overhead. These mixed-up areas made it harder to tell what features were old and what were formed more recently. A strange effect was seen in the way shadows fell at sunrise or sunset on the far side. When the sun was low, long shadows made small rise and dips in the ground clearer. Some places revealed new ridges, pits, and even faint lines not seen before. Scientists used these special times to study the surface and find hidden marks. In this soft light, thin cracks opened up, and old buried craters were easier to see. Every new discovery added a detail to the map of the far side's land. Some lines and circles did not fit any simple story. Sometimes they crossed each other in strange ways. There were spots where one line would cut across a groove, only to be lost under a new crater or buried by shifting dust. In other places, an old circle would melt into a newer formation, showing that the ground had been changed more than once. This mixture of shapes, new and old, showed that the far side was not frozen in time. It had changed many times, each event leaving a trace on the surface. New questions arose from each detail found in the photographs and maps. Why did the far side have so many of these strange patterns while the side facing Earth did not? Were the lines, grooves, and ridges formed by impacts, or did they come from processes deep inside the moon? Could some marks have been made by rocks falling from space and breaking up before hitting the ground? Did heat and pressure inside the moon create cracks and faults as the crust slowly shifted over billions of years? To answer these questions, scientists looked at patterns in shape and position. They used data from cameras, heat sensors, and radar images. They compared where lines, circles, and ridges appeared, trying to find connections that could explain the moon's changing land. Every mission sent more pictures and better measurements, helping teams form new ideas. Later missions brought even more detailed maps of the far side. With better cameras, scientists were able to see very small features that had once been invisible from Earth. Some new formations were only a few meters wide, showing that not all changes happened long ago. Some must have formed more recently, after the surface was already covered in older marks. One of the biggest puzzles came from groups of marks that seemed to run parallel or crisscross in a set pattern. These groups sometimes formed shapes too regular to be by chance. Lines of small craters or long cracks appeared side by side, as if shaped by the same push or pull in the ground. Some groups followed the edges of large basins, while others broke through mountain ridges. By counting and measuring, scientists noticed that the size and length of these marks often matched the place where they appeared. Deep inside big basins, the cracks and faults were longer and smoother. Near the edges, they were broken and rough. All these observations suggested that huge events must have shaped the far side. Some scientists believed that waves of force from ancient impacts traveled through the moon, breaking the surface in patterns that remained for billions of years. Others thought that as the moon cooled and shrank, the crust was forced to break, leaving behind lines, faults, and ridges. Another idea was that slow stretching and squeezing of the land shaped many of the lines over time. Sometimes, strange shapes even appeared under newer layers of dust. Special cameras measured small changes in heat and found curved and straight lines below the surface. In some cases, patterns buried by many meters of moon dust were seen only with radar that could scan deep underground. These hidden shapes showed that marks from very early times could still survive, only hidden under softer ground. Patterns on the moon's far side also affected how light reflected back to space. In places with many ridges and grooves, sunlight bounced off at strange angles, making the ground look brighter or darker than surrounding areas. Sometimes, these changes in brightness outlined shapes that were hard to see in normal pictures. Using this light, Experts drew new outlines of ancient basins and long-lost lines that only showed up under special conditions. Even very tiny features gave new clues. Some craters had bumpy floors or strange, spiral-shaped deposits inside. These twists and uneven areas may have been shaped by sliding rocks or thin gases moving after an impact. Sometimes, odd marks in the dust appeared that matched the wind patterns found on other planets, but the Moon's air is nearly gone. Each detail was checked and measured to find an answer. As the years went by, teams working together across different countries used better tools to study the Moon's shapes. With satellites, they mapped the heights and depths of every spot on the far side. They created full, three-dimensional models of the land, showing each ridge, drop, and curve. These new maps let them check how patterns connected in real space, not just in flat images. The far side's odd shapes became a guide for future missions. Scientists used the positions of ridges, grooves, and faults to choose where to send new landers and robots. Some targets were chosen because they offered a mix of old and new features. Others were picked so that scientists could dig or scan below ground to see what older patterns were buried under fresh dust. Each strange mark and formation helped build a timeline for the Moon's past. The circles, lines, and ridges showed which impacts happened first and which changes came later. By studying how these shapes overlapped, researchers guessed the order of events and the forces that shaped the land for so many billions of years. Sometimes, the weird marks pointed to things happening deep below the Moon's surface. Some patterns matched what might happen when warm, molten rock moved below thick crust. In other cases, slow changes in temperature broke the ground in certain ways. Still, not every pattern could be explained by simple theories. A few shapes and alignments seemed to break all predictions, showing that the far side still had secrets waiting below. The more scientists found, the more they wanted to understand how all these unusual patterns fit together with what was hidden deeper underground. As research went on, people began to build new kinds of instruments for future spacecraft. They hoped to scan under the Moon's surface, looking for more clues about how the far side was truly built. The next steps would be guided by everything learned from these strange, beautiful, and sometimes puzzling formations. Even as scientists searched for answers under the Moon's surface with new machines and cameras, something else began to happen that brought new attention to the far side. Missions became more advanced, and people no longer had to depend only on machines to explore the Moon. The United States started to send astronauts there as part of the Apollo program. Sending humans into space was a great step for all of science, and it gave everyone an opportunity to learn about space in new ways that could not be done with robots alone. The Apollo missions used very large rockets to send astronauts around the Moon and, later, to land on it. When these crews traveled in their command modules, they always circled the entire Moon before coming down to land or returning to Earth. As the ships moved around the far side, something strange always happened. Because the Moon itself blocked their radio signals, once the astronauts crossed behind the far side, all communication between the spacecraft and mission control on Earth stopped. There was silence. Nothing could be heard or sent either way. This happened every time. The silence would last from about 30 minutes to almost 1 hour, depending on the path of the spacecraft. During these silent moments, the astronauts floated in their small spacecraft above the side of the Moon that no one on Earth could see. They could look out through the windows and watch the strange marks, lines, and craters that had been found by earlier machines. It was a time for them to feel both alone and amazed, because they were the only people to see these places with their own eyes. They took photographs and made careful notes about what they saw, adding more to the maps and studies already started by robots. While this was special, something very strange was reported by more than one crew. As they floated above the far side, with radio silence cutting them off from Earth, a few astronauts reported hearing odd sounds in their headsets. Instead of only silence or static, there were strange musical tones, odd whistling noises, and sometimes a kind of whooshing sound that lasted several seconds. These sounds happened when no one on Earth could contact them and when no other signals were supposed to reach that part of space. The first known account came from the Apollo 10 crew in the year 1969. While circling the far side, they suddenly heard what they described as space music. The sound changed in pitch, almost like a radio moving up and down quickly. The astronauts listened with surprise. They talked to each other inside the module, asking if everyone else could hear it too. All of them agreed that something strange was coming through their headsets. Later, when they finished their path around the moon and regained contact with mission control, the astronauts spoke cautiously about what they had heard. They worried that if people thought they were confused or ill, they might not be allowed to fly again. Some reports said the astronauts were careful in their words when they handed over the flight tapes for study. The sounds did not stop with just one mission. Later, Apollo crews also reported odd noises during their own trips around the far side. Sometimes the descriptions were different. One group heard soft beeps and faint squeals, while another compared the sound to a faraway musical instrument being played in a room next door. Each incident happened only when the spacecraft was hidden behind the moon and cut off from calls to Earth. Each time the astronauts returned to the near side, the noise would disappear and everything would go back to normal radio chatter. NASA scientists worked hard to explain these noises. They suggested that in the unusual conditions above the far side, the radios inside the astronauts' headsets might pick up signals from other instruments in the module. Some experts said it was likely just a mix-up of two radios inside the same system, with signals crossing each other and creating odd sounds. This is called radio interference. Others thought maybe particles or energy from space could mix with the electronics, making noise that the human ear changed into a kind of tune or whistle. However, these explanations did not answer all the questions. Not every radio interference makes the same sound, and the musical nature of the noises made some people wonder if there could be another source. Some thought the moon itself might have something to do with it. Maybe something in the rocks or underground formations changed the energy around the spacecraft as it passed overhead. There were even theories that very thin atmospheres or unknown gases trapped in the moon's old craters might create some kind of sound as the ship moved above them. The tapes of the space music were kept safe and studied by many teams. For many years, the reports were not shared with the public. Only when people started to ask about the Apollo missions in more detail did NASA release information about these events. Even then, the sounds from the far side continued to puzzle those who listened. The mystery grew because some astronauts said the noises were loud enough that they talked about it over the radio as soon as they returned to the near side. Others said that as soon as the module crossed the border between the far and near side, the noise faded to silence. Over the years, every possible reason was considered. Scientists checked the design of the modules. They also tried to repeat the interference in test labs, but could not make the same kind of music. It was important to remember that the moon has almost no air for sound to travel through. On Earth, sound can travel through air, water, or even ground. But on the moon, sound cannot move in the same ways. These facts made the mystery more difficult. If the sound was coming from outside, it could not be air or wind. If it came from the moon's ground, it had to reach the module in a new and different way. Some people believed the answer must be fully technical and that no new theory was needed. Others wondered if the unique nature of the far side, Its hidden surface, deep craters, and dense rocks might have unexplored effects on how energy or signals moved through space. These questions remained without clear answers, even as new spacecraft and robots continued to circle the moon and send more data home. For the astronauts, the moments of silence above the far side became something to prepare for before every flight. They trained for how to handle the quiet, checking systems very carefully and making the most of the time by taking notes and pictures or simply looking out at the strange surface. Even with all the wonder and danger of space travel, some said these moments had a special kind of peace mixed with the unknown. After the Apollo missions, the reports of strange sounds became well known. Some writers and filmmakers used these stories for inspiration, imagining what might cause noises in the silence above another world. The far side became not just a place of strange ground and old craters, but also a place that made people question what else could be happening there. The search for answers led teams to try new types of measurements every time they sent up a spacecraft. More advanced recorders and better microphones checked for any unusual sounds. So far, robots circling the moon have sent back only normal beeps and background static, but some believe new effects could be found with improved tools and sensors in the future. The strange reports did not stop scientists from planning and building new ways to learn about the moon. After Apollo, no one sent people back for many years, but electronic explorers kept working. They brought pictures of new patterns, and they began to measure things under the surface as well as above. Each new bit of information added another piece to the puzzle that had started with simple questions about the ground. These quiet times above the far side also made scientists think more about what was hidden beneath the surface and how it might affect the moon's energy. Some craters on the far side had odd electrical readings, and a few spots reflected radio waves in unusual ways. This led people to wonder if there could be special underground structures or types of rocks that affected signals. Even though the technology was not yet advanced enough to dig deep, future missions would be built with new ways to look under the ground. With every flight around the far side, the importance of understanding what was happening both above and below the surface grew. Strange moments in complete silence pushed people to ask new questions about how energy and matter could work in places that, until a few years earlier, no human had ever visited. With each discovery, everyone realized how much there was still to learn, and every mission brought the hope that new clues could solve not just the old mysteries, but ones they had not even thought to ask before. Families and children followed the missions in books and on television. The idea that astronauts had found music and odd sounds in silence made news. For many people, it was the first time they truly understood how different and mysterious the moon's far side was. Astronauts returned home and talked about what they had seen and felt, but the stories of strange sounds always held a special place in people's minds. Many wondered if the reports of music were a sign of something never found before. Was the moon still holding secrets, not only in its shapes and rocks, but also in the way it might use energy or sound? Future explorers would need to be ready for anything. Scientists now planned missions that could check for new kinds of signals, listen more closely, and even dig to test if strange forces lay under the dust. The link between the quiet moments above the far side and the possibility of new mysteries beneath the surface pushed space agencies to improve their technology. If machines could scan deeper, perhaps they would find unknown types of metal, caves, or even empty spaces where strange signals were born. Each year, computers and sensors became better at sending and receiving faint energy, helping everyone learn a little more about what existed beyond human sight and hearing. Because the moon is close to Earth, finding answers there could also help people understand other worlds. Some believed that if signals or sounds could shift and change above the far side, there might be lessons for working in deep space or for building bases on other planets. These ideas brought hope, and they made sure the exploration of the moon would keep going for generations. All these efforts, from astronauts listening in silence to robots measuring rocks and dust, added to a single story. The far side remained a place of mystery, but now there was a roadmap to send better machines, to study signals and sounds, and to use every new clue to solve the oldest questions. The next scientific missions would be shaped by every report, every strange sound, and every unusual picture, keeping the spirit of discovery alive and strong. The drive did not stop at strange sounds and empty time. Even while experts worked to explain every detail of what happened on Apollo, bigger questions began to grow about the deeper layers of the far side. Maybe, some thought, the moon still hid its greatest surprises in places people and robots had never yet reached. This idea set the stage for even more careful exploration, using new kinds of radar, sensors, and tools designed to look through dust and rock where human eyes could not go. As the possibility grew that great secrets might be hidden beneath the far side of the moon, teams of scientists around the world wanted to see deeper than ever before. It was clear that the surface held many clues, but the biggest mysteries could be below the rocks, dust, and old craters. Technology needed to change so people could scan underneath, study layers, and look for things that no eye or camera had seen before. New missions would use special tools to measure, scan, and map the inside of the moon. This work required strong spacecraft, careful planning, and new ways to gather information. The first step was to use better cameras and instruments from orbit. By the end of the 20th century, space agencies developed robotic spacecraft equipped with cameras that could take thousands of pictures in a single trip. These pictures were sharper and brighter than any taken before. At the same time, these spacecraft carried other tools to measure heat from the surface, detect special kinds of light, and even send radar pulses into the ground to see what was buried. As the spacecraft circled the far side again and again, every detail, every hill, crater, and ridge was mapped, not only on the surface, but sometimes up to many meters underground. Radar became one of the most important new tools. Radar is a kind of energy that can pass through rock and dust and then bounce back, letting scientists build pictures of things below the ground. Some probes sent radar waves deep beneath the far side and received signals back that showed layers, buried shapes, and hidden walls. These radar pictures looked different from normal photographs. Instead of seeing just the top layer, scientists now had a kind of map that could show what lay underneath, sometimes to depths of tens or even hundreds of meters. Along with radar, another set of instruments called gravimeters measured small changes in the moon's gravity. Gravity is the pull that keeps things on the ground. On the moon, gravity is weaker than on Earth, but it is not the same everywhere. By carefully noticing where the spacecraft flew faster or slower, higher or lower, scientists could tell if there was heavy or light material below the ground. If a metal object or a very dense rock was buried in the far side, it would pull a spacecraft's path slightly, even if no one could see it directly. These movements were measured down to tiny amounts, smaller than a hair's width. Sensors also looked for magnetic signals. Some rocks and metals carry magnetism. If there were large pieces of metal, strange rocks, or remains of old impacts, the sensors could find weak signals sent from deep in the moon. By collecting this data for many years, scientists built maps showing which parts of the far side might have something special underground. Work began to match everything together. First, teams put radar, gravity, and magnetic maps over each other, looking for places where the readings matched. If radar showed a hard, flat shape below the ground, and gravity was stronger right above the same spot, It suggested something heavy was under the dust. When magnetic sensors picked up a signal in the same area, the guesses grew stronger. Perhaps there was a big buried object below. For many years, these measurements showed surprises, but not many clear answers. The far side was full of places where gravity was a little stronger, where rocks were thicker or harder, or where radar hinted at shapes below the surface. Many of these places seemed to match the old impact basins and large craters seen on the surface. Others did not fit any known crater, leaving mysteries for future missions. Then, scientists took a new step. They set out to study the oldest and largest basins on the far side, especially the South Pole Aitken Basin. This impact zone is huge, stretching more than 2,000 kilometers from end to end. Gravity readings above this basin showed something very unusual. There was a strong signal suggesting very dense material deep underground, much heavier than the normal lunar crust or rock above it. This was not just a small patch, but a circle hundreds of kilometers wide. When the data from different machines came together, the mystery grew. The radar found something hard and flat beneath the center of the South Pole Aitken Basin. The gravity data showed there was a lot of mass in that same area. Magnetic maps also picked up some weak signals, suggesting special kinds of rocks or even metal. People began to think there was something very large, dense, and strange buried under the far side's biggest crater. Teams ran computer simulations, creating models to see what could explain these signals. One idea was that long ago, a gigantic asteroid hit the far side and left behind not only a huge basin, but also a core of metal or other heavy material deep below. Another idea was that when the impact happened, dense material from deeper inside the moon was pushed upward and then settled into a wide patch under the crater. This could also make the gravity stronger, the radar bounce back harder, and the magnetic readings stand out. Whatever the reason, there was now strong evidence that the far side of the moon, especially in these old basins, had buried objects or zones much heavier and different than what was seen anywhere else. These discoveries changed what scientists thought was possible. It meant that parts of the far side were not just different on the surface, but through many layers deep inside too. The radar maps kept showing more interesting shapes below the surface. Sometimes they found thin, flat sheets, as if ancient lava once flowed under the ground and stopped before it reached the top. Other places had strange lumps or ridges buried by dust, showing that impacts or other processes could push land upward and then cover it again over time. A few areas had signals that could only be explained if there were pieces of pure metal, much denser than normal rock. All of these findings led to new plans for exploration. Scientists wanted to send landers with drills to take samples from deep under the surface. Robots were designed with arms and tools that could dig and collect rocks, dust, and even bits of metal or unknown materials. The hope was that by touching and testing materials from below, they could finally discover what gave such strange radar, gravity, and magnetic readings. Spacecraft also carried cameras that could measure changes in heat, since different materials get hotter or colder at different rates. When a buried object changes how the ground above it heats up in sunlight or cools down at night, the cameras could pick it out, even if it was well below the surface. These thermal cameras found places that stayed warmer or cooler than expected, matching with radar and gravity data. This was another clue that locations with strange signals really did hold something unusual underground. On Earth, scientists studied the moon samples brought home by the Apollo missions and earlier Soviet missions. Even though these came from the near side, some pieces had strange patterns inside, small flecks of metal or bits unlike normal moon rock. This showed it was possible for pieces of metal or heavy rock to exist on the moon. Still, nothing from those missions matched the huge amounts suggested by the gravity and radar scans of the far side. Ideas changed over time as measurements improved. Some researchers thought the buried metal must have come from a single great impact, while others guessed maybe several smaller impacts added dense material layer by layer. There were also ideas that inside the moon, its own material slowly moved for billions of years, letting parts of its heavy core rise up in certain places and then freeze in place. What made the situation even more interesting was that these zones of dense material could change how the moon moves, how it turns, and even how it affects Earth. Some experts wondered if the hidden objects could make the moon wobble a little or change the strength of its pull on our planet's tides. This is because when weight is not spread evenly, the whole balance can shift slowly over time. Measuring these effects became a new goal for moon missions and telescopes on Earth. Detecting metals under the ground of the far side also gave ideas for the moon's early life. If the moon was once very hot and partly melted when it formed, heavy materials should have sunk to its core. The finding of metals much closer to the surface could mean very unusual events happened. Perhaps ancient impacts not only made holes, but actually broke through the crust and dug into the moon's deeper layers, throwing up metal, rock, and melted stone and letting some settle back just under the dust. Maybe it was a process that only happened on the far side, or maybe hidden metal zones are waiting under the near side as well, still to be found by future tools. The more data scientists gathered, the more it became clear that new missions would be needed, and that those missions had to be focused on collecting even better information from deep beneath the surface. Countries began to prepare new spacecraft, robots, and future human expeditions. Some missions planned to land inside the giant basin on the far side, while others aimed for ridges and craters where the signals were the strongest. Another idea was to look for clues about what might lie underground by measuring tiny changes in how surface dust moved or settled. Some spacecraft dropped impact probes on purpose and listened for how vibrations traveled through the ground, like a bell ringing. If the signal moved fast or slow, spread out or bounced, it could suggest where the material below changed from one type to another. The study of moonquakes and how shock waves moved became one more way to peek below the surface. As robots kept sending back data, computer models on Earth became more advanced. They could now build three-dimensional pictures of the far side below the ground, showing layers, lumps, possible metal objects, and old lava flows. These models were constantly tested against new data from radar, gravity, thermal, and magnetic scans. If a model did not match real results, it was changed or thrown out. The work was slow, but every year brought new discoveries. Even school students and people at home helped. Sometimes, scientists asked them to look at images or patterns from spacecraft and help spot new features. This used the power of many eyes and minds working together. It showed that learning about the moon's far side is not only for experts, but for everyone interested. The next series of questions asked how deep the metal and strange rocks might be buried. Could they ever be reached by drilling or digging? Is it safe for future landers and astronauts to touch or study them? Or are there dangers from strange chemicals or energy? If some buried objects were made of pure iron or other metals, could people ever use them for building or other needs in the future? Every answer led to new ideas and dreams about both the moon and all of space. There were also hopes that finding big pieces of metal or special rocks might help understand the deep history of the solar system. Maybe these objects are leftovers from the very first days of building planets. They might hold clues about what kind of events were common long ago, and if other worlds nearby went through the same kind of giant impacts. The search for heavy, hidden materials on the far side of the moon changed the way science approached space. Planning each mission became like solving a puzzle with many pieces, matching surface marks, shapes from radar, signals from gravity, and maps from thermal cameras. Each part had to fit before people could feel sure about what they were seeing. As more was learned, the questions changed, moving from what is under the ground to how did this get here, and what does it mean for the Moon and for Earth? The journey to explore beneath the surface was just one part of a larger effort. At the same time, spacecraft circled higher to look at the biggest patterns, and robots prepared to land and dig. The dream was always to find the true story of how the Moon's far side became so special, and what might be learned from studying these ancient secrets. All the work done so far gave a map not just of the land people could see, but of the hidden world just below the dust. In the future, with better machines and new ideas, even deeper layers could be studied. This would help reveal everything that makes the far side unique and could change how everyone understands not only our Moon but the history of all planets in the solar system. As scientists made new maps that included not only the Moon's surface but also the layers hidden below, questions soon grew about what these buried metal objects really were and how they got there. The readings from special instruments were clear. Something very dense and unusual was hidden under the dust and rocks of the far side. The size of these objects was massive. Some of them stretched over areas that were hundreds of kilometers wide, much bigger than most craters or known features on the Moon. Because these objects were so heavy and dense, they could be seen by changes in gravity, by radar images, and sometimes through magnetic signals. The mystery of the hidden metal became important for many reasons. Scientists everywhere wanted to know if these objects were just rare types of natural rock, or if they were something special left behind from a very old event. The fact that metal objects of this size and depth were not found on the near side of the Moon made the puzzle even more interesting. Some experts thought the answer came from the Moon's past. They believed that billions of years ago, the far side was struck by a huge asteroid or comet. This space object had to be very big, possibly more than 200 kilometers wide. When it crashed into the Moon, it created a giant basin. This basin is now named the South Pole Aitken Basin, one of the largest impact craters in the whole solar system. The power of the impact was so great that it dug deep into the Moon's crust, pushing material from deep inside up to the surface and maybe leaving parts of the asteroid itself behind, buried under the ground. To test this idea, scientists made computer models of the crash. They found that if a giant space rock hit the Moon with this much power, some of its heavy core could stay beneath the surface, mixed with the Moon's ancient crust. Over millions of years, dust, rocks, and lava would cover the remains, leaving only signals for today's machines to find. The models also matched the gravity and radar readings that were measured during recent missions. But there were other possible ideas. Some scientists thought that the metal objects might have formed from the Moon itself. When the Moon was very young, it was hot and partly melted inside. Metals like iron and nickel are very heavy and would slowly sink down into the deepest parts, creating a core at the center of the Moon. However, if for any reason the movement of hot rock and metal was uneven, it could create pockets of metal closer to the surface. This might explain why there was so much metal in certain places on the far side. Other researchers believed that the far side went through special changes that did not happen on the near side. It's possible that as the Moon cooled and changed shape, cracks and giant faults opened on the far side, letting metals move higher than normal. Over time, these metals would freeze and stay where they were, hidden under layers of dust and solid stone. The thicker crust on the far side probably helped keep the metals trapped and preserved for billions of years, while the near side lost its metals as lava flowed more often and changed the land. Scientists also wondered if the heavy metals underground could change the way the moon moves in space. When something very heavy is in one place, it can affect how the whole moon turns and spins. Some measurements showed that these hidden objects may have made the moon's orbit less steady over time and even changed its gravity in small but important ways. Because the moon's gravity pulls on Earth's oceans and helps make tides, knowing about these heavy objects is important for understanding the balance between the two worlds. Not everyone agreed about the origins of the metal. Some experts suggested that maybe the signals showing buried metal were caused by very dense lava left when the moon was still active in its early years. This lava could have cooled in large underground pools, leaving behind big areas of heavier and different rock. Another theory was that these metal-rich areas were once part of the moon's very first crust, pushed aside as the huge South Pole Aitken Basin formed. To help answer these questions, samples from the moon needed to be studied. Most samples brought back during the Apollo missions came from the near side. These rocks had some metal, but never as much as the readings suggested for the far side. For this reason, new missions to the far side were planned, with hopes that robots would one day collect samples right over the strongest gravity and radar signals. During each new mission, spacecraft sent back millions of pieces of data. Instruments measured not just gravity and magnetism, but also the energy of molecules in the rocks, the shape of dust grains, and even the way light reflected from each spot. These tiny details helped build a more complete picture of what was under the surface, making it possible to test each new idea. Some of the most exciting clues came from looking at how the metal was spread out. If the metal came from a single huge impact, it would likely be mostly in one place, and its shape would match the giant crater or basin above. Mapping of signals showed that the biggest heavy object did match the old South Pole Aitken Basin, which supported the asteroid impact theory. But smaller metal-rich areas were found in other craters that did not always have the same shapes, which meant there may be more than one cause. As data grew, new questions were raised about what happened after the giant impact. Some scientists believe that when the asteroid hit, melted rocks spread for hundreds or even thousands of kilometers, carrying pieces of metal with it. As the moon cooled, these metals became trapped under layers of crust, making it look like there were many patches, even if they all came from one event. Other experts said that each large impact long ago might dig up different kinds of metal from the lower layers, spreading them to places where gravity and radar could find them today. Researchers did not only study the moon's far side, they looked at impacts on Earth, on Mars, and on other moons in our solar system to see if metal objects could survive huge crashes. On Earth, they found that some of the biggest craters have rocks rich in metal deep below, but nothing as big or as dramatic as what is seen on the far side of the moon. Questions grew about what these objects could mean for future space missions. If heavy metals like iron or nickel could be reached by digging or drilling on the far side, could people use them for building or making machinery in space? Scientists also studied if digging in these areas would be safe, or if there might be risks from touching very old metals and rocks that have never been reached before. If metals really did come from a giant space impact, there could also be clues about the history of other planets. Puzzles also appeared in the way these heavy objects changed the surface above them. Some places on the far side had slightly higher hills or different patterns of cracks and ridges right above the buried metal. In a few cases, dust collected in unusual ways and ground temperatures were different than nearby areas, showing that the objects below might still be affecting the moon's land today. Some patterns in the craters above these metal spots were different as well, with fewer impacts or more odd shapes than in places without metal. As people learned more, another idea became important. If many planets and moons have hidden metal objects left from big impacts, maybe this is a normal part of how worlds are built and changed in space. That could mean the heavy materials under the far side of the moon are important, not just to its story, but also for understanding Earth, Mars, and the moons of Jupiter and Saturn. Teams on Earth built stronger computer models and compared new and old readings from moon missions. They found that the buried metals matched best with what is called an impact core, meaning a big piece of an asteroid's metal heart may still sit under the South Pole Aitken Basin. The weight, shape, and magnetism all matched this idea well, but as always, new data was needed to be completely sure. Scientists then wondered if the metals below the far side played a role in shaping the very thick crust on this part of the moon. Perhaps the big impact brought up so much heavy rock that it changed the way crust formed for millions of years. These metal areas may have held heat differently, causing the upper layers to cool and crack in new ways. They may also have pushed against older rock, making cracks, lines, or faults along the whole basin. Some studies even suggested that the heavy metals still help shape the moon's movement. By changing the balance of weight under the surface, the moon's movement around Earth might shift over long periods of time. If true, scientists would need to think about these effects when planning future bases, missions, and even how the moon's gravity will affect tides far into the future. Every new piece of evidence showed just how little was known about these hidden metal objects. The next step for many researchers was to get samples directly from above the strongest gravity or radar readings. Robots were designed with better drills and tools to reach deep, take out pieces of rock, and test them in small labs inside the machines. This would let people study the true metal and learn exactly what it is made of, how old it is, and where it came from. Talk grew about sending human astronauts to the far side to help dig and explore. These missions will need to be safer and more advanced than the old Apollo trips. Astronauts must work in places with different gravity, extra dust, and cold nights that can last for many days. They must also find ways to avoid disturbing signals and metal objects before all science tests are finished. While plans were made for these future missions, some satellites continued to study the far side from above, sending streams of gravity, heat, and radar data back to Earth. Each week, new maps showed more detail, filling in the story of the hidden metal objects and the strange land above them. Even as possible answers came into view, important questions remained. Is the buried metal really from space or from the moon itself? Does each object match one giant impact, or were there many smaller ones? Are all the hidden pieces metal, or are some made of very dense rock or volcanic lava? And what effect will these objects have on the moon, on Earth, and on any future person who steps onto the far side? While the world waits for new samples and missions to bring back more data, the mystery of the hidden metal under the far side remains a topic that brings together many areas of science. Geologists, astronomers, engineers, and students all keep searching for answers. Each map, each drill test, each piece of dust and rock gives one more clue about how the moon was formed and what powers and shapes our closest neighbor in space. Everything learned so far shows that the moon, especially its far side, has much more to tell about the solar system and about how planets and moons grow and change over billions of years. The search for truth continues, using every tool and every bit of knowledge that people can find. As the search for answers about the strange buried metals on the far side of the moon grew, teams of scientists in many countries started to work together more closely. There was so much to learn, and new machines were needed to get better results. People built stronger robots, bigger telescopes, and faster computers, all to help solve the moon's puzzles. Each discovery brought new questions, and every team wanted to add their piece to the story. This made science about the far side a worldwide effort. With each new mission sent to the moon, information was collected about craters, soil, hidden metals, old lava, and layers below the dust. Special spacecraft went into orbit and circled the moon for many months, sending back many thousands of pictures and measurements. Some spacecraft were designed to scan the ground with radar. Others dropped small capsules that would crash on purpose, sending back signals as they hit, which helped measure the way the ground and rocks responded to shaking or impacts. Many landers carried small labs that tested the chemical makeup of dust and stones, checking for iron, nickel, and other rare parts. Scientists spent long hours studying the photos and maps. They compared the patterns of craters and grooves, counted how many of each kind were found in every area, and built three-dimensional models to show the high ground and low ground. Experts used computers to simulate or copy how impacts happened. These models helped guess what would happen if a giant rock hit the moon or if lava rose up from inside. By matching different models against what was really seen, scientists could better understand which ideas made sense. A key part of these studies was asking why the far side and near side are not the same. The models showed that impacts happened on all parts of the moon, but the results were always different on the far side. There, many more craters and deep basins could be found. The ground was rougher, with more sharp edges. There were almost no large, smooth seas, or maria, as on the side facing Earth. The surface was older, filled with traces of billions of years of impacts and slow change. Some teams focused on the patterns left by old impacts. They traced lines shaped by shockwaves that had spread from places where huge space rocks hit. By studying the shape and direction of cracks, grooves, and the arrangement of smaller craters, the time and order of past impacts could sometimes be guessed. This was useful to build a timeline of what hit the moon and when. Other teams worked on studying the minerals and chemistry of the ground. Samples brought by robots were tested in tiny pieces under powerful microscopes. These tests showed how rocks in one crater could be different from those in another. It was found that the far side had more light-colored rocks with much less iron and other heavy metals than the near side. Still, in a few special places, signs of very dense material below the ground matched the gravity and radar maps. A big focus was the South Pole Aitken Basin, where the heaviest buried metal was found. Researchers checked not only the surface but also the shapes of the hills, the pattern of small craters, and the way dust and heat acted in the area. They compared this with other basins on the far side, such as the larger walled plains and long grooves. Some features were very old, going back close to 4.5 billion years, almost to the time when the moon first formed. Scientists used satellites to study how sunlight and temperature changed hour by hour and day by day on the far side. Thermal images helped to spot places where buried materials might affect how hot or cold the surface became. Areas with hidden metals or old lava flows sometimes stayed warmer or cooled off more slowly at night. These temperature studies matched other clues about what might be below the dust. Teams also used new types of telescopes placed on the ground, in space, or even on the moon itself. These telescopes measured light and energy at wavelengths not seen by normal eyes. The results helped learn which minerals and metals made up different areas, even if they lay deep under the surface. As more data arrived, scientists built computer programs that could test ideas quickly. These programs helped sort millions of pieces of information, searching for patterns in the size of craters, the depth of basins, the balance of different minerals, and the places where radar or gravity was strongest. The computer programs made maps with colored shapes, lines, numbers, and other signs. making it easier for teams to decide where to look next. Not all the work was done by experts. Citizen science projects let everyday people help too. On some websites, people at home could look at pictures sent from space robots and mark places that looked strange or interesting. If many people marked the same area, scientists could check more closely. This helped find new features and saved time for the teams at research centers. Countries shared information by publishing it in books, magazines, and online reports. Many teams from different parts of the world joined their data. The United States, Europe, China, India, Japan, and Russia all sent missions to the moon's hidden side, and sometimes they worked together to plan new goals. Each country's tools helped fill in blanks on the map. For example, one country's lander could test for magnetic or heat signals, while another could map the ground in fine detail. Scientists met at conferences and talked about ways to improve future missions. Some suggested building robots that could dig deeper holes, drill through rocks, or carry tiny labs to study new minerals on the spot. Others wanted better sensors for measuring magnetism, vibrations, and heat in places where old metal might change the ground in ways never seen before. A problem was that sending robots to the far side of the moon is harder than landing on the side facing Earth. Radio signals cannot go straight through the moon, so special satellites need to be sent into space to relay messages between the robots and teams back home. This meant some missions had to spend years planning, each step depending on the success of the one before. The first time a lander touched down on the far side, people celebrated all around the planet. It showed what could happen when many teams worked together and planned carefully. As studies continued, some of the old mysteries grew deeper. Even as more was learned about buried metal, there were still strange patterns in the ground, odd lines and craters that could not easily be explained by impact or heat. Some areas showed changes in gravity but not in radar. Other places had heat changes but no sign of heavy metal. This meant more than one force was at work, and the true story was more complex than any single theory. One of the biggest questions now was what all these clues could tell about the birth and early years of the moon, and, by connection, more about the beginnings of Earth and the solar system. Every rock tested, every chemical checked, every hidden signal sent from the far side gave another bit of the moon's long story. By understanding how the far side formed and changed, it might be possible to learn how other planets grew, how impacts built up worlds, and how metals and minerals moved over billions of years. Each team had to be careful, testing every idea, repeating every experiment, and checking results from different countries and missions to make sure they were correct. This took patience, but it made the answers stronger. The sharing of information and teamwork showed that science can be faster and better when countries work together, even across big distances and many languages. Research groups set up new training for future scientists. They taught young students how to read satellite maps, use computer programs, and study minerals under microscopes. Schools shared pictures, held classes, and asked children to guess what could be behind each new crater or line. This made the whole world feel part of the search, and it brought new excitement to learning about space. Robots and landers continued sending back data year after year. Some found places where the ground felt hollow, where vibrations moved differently than in solid rock. Others drilled a few meters into the ground and picked up samples that were tested for age, minerals, and metal. Each sample helped check the ideas built by computer models, making sure they matched what really existed under the dust. The search was not just about the past. Plans were made for new uses of the far side in the future. Its quiet, hidden face, safe from the radio noise of Earth, was seen as a perfect place for space labs and telescopes. Scientists talked about sending machines that could listen to distant space signals from the deep universe, learning more about stars and planets far away. Every time a new robot landed or a satellite circled overhead, the map of the far side grew clearer. Some areas that were only guesses a few years before now had detailed pictures, layers, and strong evidence of what was buried below. The story became richer than anyone imagined at the start. What began as a search for hidden metals turned into a story about how the Moon, Earth, and all the planets have changed from dust to rock to worlds full of history. The teams working to answer the far side's mysteries continue to face problems. Landers still must cross dangerous ground, and every mission must plan for hours when signals drop and silence fills the air. Energy is hard to collect with the sun low on the horizon, and cold nights on the Moon can last for 14 days or more. Yet, every problem makes the teams stronger. The world learns how to build better machines and how to work in places where human hands cannot go. Some experts dream that one day people will walk on the far side, drill deep into the ground, and bring back rocks that hold answers no robot can find. For that to happen, science teams keep making better suits, better drills, and safer ways to send signals between faraway lands. Work continues, each step planned by the lessons learned from every mission. To many, the far side of the Moon now feels less like a story from ancient times and more like a real place, one that could teach about space, about ancient impacts, about metal buried deep, and about how humans can work together to solve the hardest puzzles. Each map, each photo, and each sample is part of that new understanding. With every question answered, another appears. There are still old craters whose age is a mystery, hills and cracks where no one knows how they formed, and hidden shapes in the ground no camera has seen. But every test and every mission brings the world closer to finding those answers. The far side invites researchers, students, and explorers to join the search, learning not just about the Moon, but about what it means to find truth, work together, and look for new beginnings in the universe. Learning about the far side of the Moon has brought new hopes and plans for the future. As scientists, engineers, students, and people everywhere watched robots and spacecraft find secrets in the rocks and under the ground, a new idea grew. The far side, once only a distant mystery, can now become a place to use for important new science, technology, and discovery. It is not only a place to study old craters and hidden metals. It is now seen as the best place near Earth for the next steps in space research and exploration. The far side always faces away from Earth. As a result, it is protected from radio signals and many kinds of noise that come from our planet. On Earth, people use radios, cell phones, electric lines, satellites, and many other things that send out strong signals. These signals can cover the air with energy and make it hard to listen to quiet sounds from space. But on the far side of the Moon, there are almost no signals from Earth. There is only the quiet of space. This quiet is very important for scientists who want to study the sky. Many teams want to build large listening devices called radio telescopes on the far side. A radio telescope is an instrument that can pick up very weak signals from far away in the universe. On Earth, these telescopes are often bothered by human-made noise. The far side of the Moon gives a perfect place to hear these signals clearly without being blocked by Earth's noisy atmosphere. Building a radio telescope there would help scientists learn about the very early universe, about signals from the first stars and galaxies, and about strange objects in deep space. If a group of radio telescopes were spread over the hills and craters of the far side, they could work together to study new parts of the sky. Each one could be shaped as a big dish or a series of wires placed over the ground. Some ideas are to use simple wires, stretching them in wide lines over the dust, using special shapes that can pick up very old signals. signals made before the sun and planets first came to be. Some scientists from the United States, China, Europe, and other parts of the world have already made blueprints and small test devices for these moon telescopes. Astronomers are very interested in using the far side for this reason. The sky there is always dark for many days, and there are no cities or machines to create problems for light or sound. Even a small telescope or listening dish on the far side can find signals that cannot be heard from anywhere on Earth. Those signals can tell about the universe when it was young, about black holes, about strange radio waves, and about other galaxies. This can change what is known about the whole universe and even about how our solar system began. Another new plan for the far side is to send more robots and, in the future, people to study the ground up close. Robots today can only dig a little way into the surface, maybe a few meters at most. Scientists hope to send new machines that can drill much deeper, perhaps down to where the metal is hidden under the largest basins. These robots will be tested with stronger drills, new wheels, and arms that can work in heavy dust and freezing cold. They must be able to send pictures and data back even during the 2-week-long lunar night when sunlight is gone and temperatures drop lower than -100 degrees. Future landers must overcome many problems. The far side is full of rocks, holes, and steep places. It is hard to send radio messages to Earth from the far side, so special satellites will need to circle the moon to help carry messages back and forth. These relay satellites will help control robots, collect data, and help guide landing rockets as they come to rest on the ground. Plans are already being made by the space programs of several countries to land new robots, test deeper soil, and even practice building shelters where astronauts could one day live and work. Engineers imagine lunar bases where people could study ground samples, fix robots, and run giant telescopes or listening devices. It will be important to learn how to get enough energy, since the sun does not shine for half the time, and to protect all machines from sharp dust and radiation. One idea is to build science labs and homes under the ground. The moon has no air, so building below the surface can help protect people and equipment from radiation, temperature changes, and falling dust. Digging tunnels or even using natural lava tubes found under the far side may let astronauts stay safe for many weeks or months at a time. Teams will need to test how to do this, maybe first with small robots, then bigger ones, and later with human crews. As research on the ground becomes easier, astronauts could dig deep holes to bring up rocks that have never been touched. These new samples would help check if the hidden metals are really from old impacts or from the moon's ancient core. They could use special tools to test the rocks right there or send them back to Earth for study. The oldest rocks might give clues about how the moon formed, about volcanoes, and about big impacts that shaped all the planets in the solar system. Some scientists hope to use new computers and artificial intelligence programs to help control robots on the far side. These programs can help the robots choose where to look, how deep to dig, and can send messages home even if people are not watching every minute. The best programs might even let robots fix or help each other, making it safer to run missions when humans are still far away. Other plans suggest building small factories or using local materials. The dust and rocks on the moon have some useful stuff in them, like metals and rare elements. If robots can learn to melt, cut, and build with these materials, maybe future engineers will find ways to build towers, walls, roads, or even landing pads using only local rocks and metals. This would save years of launching heavy material from Earth and help people live and work on the far side for a long time. The moon's far side is also an important place for testing how people might live on other planets in the future. The surface there is tough, the sunlight is harsh, and the night is long and cold. If people learn to survive and work there, it will help them learn about what is needed to visit Mars or to build outposts on the moons of Jupiter and Saturn. Every mission that tries something new on the moon makes it easier to try it on worlds far away. Teams are also working on new ways to make power. Because the nights are so long on the moon, solar panels do not always collect enough light. New batteries, nuclear power devices, or even machines that use rocks or chemicals to make energy are all being tested. Some ideas are to store energy in big tanks during the day and release it at night, or to build solar panels on both sides of the moon and connect them with electric cables. The far side could also help protect powerful scientific tools for other uses. Since the surface is so quiet, it is good for looking for small changes in gravity, testing delicate sensors, or running experiments that need total silence from radio and electronic signals. A science base there could help with weather reports, tests of how plants grow with less gravity, and ways to recycle water, food, and waste for long stays in space. The moon's far side can also help with education and world cooperation. Because it takes teams from many countries to build, fly, and land robots, and people on the far side, students and teachers from all over the world can take part. Classes can talk to astronauts, use real pictures in homework, and even help decide what to search for next. Every mission becomes a lesson in science, teamwork, and discovery. Making all these plans real will need many missions and new inventions. The far side has shown it is not easy to reach or use. The ground is rough and every trip must be carefully prepared. Teams must make sure robots can work in the darkness and in cold, testing every part many times before sending it. Even with all the problems, every year there are new successes and every mission helps to fix old mistakes. Some teams want to study how hidden metals could one day be used in space projects. Mining and collecting metals on the moon could help build new machines or even spacecraft for farther trips. Using local metals may make it much cheaper and faster to work on the moon or send missions deeper into space. Scientists and engineers must learn how to dig and collect these metals in a safe way, checking for problems and making sure they do not harm the moon's environment. Plans for the future also talk about how to share what is found on the far side. The moon is close to all countries, and every discovery there matters to everyone on Earth. Groups make rules on how to share rocks, share information, and make sure that science at the far side helps all people, not just one country or team. Every new plan depends on what has already been learned. Scientists use every crater, line, and old pattern found in earlier missions to help guide new robots to safe places. They use new cameras, advanced sensors, and smart programs to monitor everything from the weather on the moon to the smallest changes in dust or heat. Every day, experts in countries around the world check data, update maps, and make future lists of goals. The moon's far side has become one of the most studied places in the solar system. Each team adds something new, sometimes a map, sometimes a drill test, sometimes a thermal image or a radar scan. All this work builds layer after layer of knowledge, giving people a real hope that what started as pure mystery can soon become a place of real progress. With so many new missions, plans, and ideas, the far side now stands ready for the next great steps in learning and building. The challenges are many, from strong radiation and long cold nights to deep dust holes and hidden rocks. Every problem, however, is also a chance to learn how to do something better. As the world moves forward, students, teachers, experts, and explorers keep turning their eyes to the quiet, hidden face of the moon. With each discovery, the line between mystery and knowledge becomes easier to cross. The far side, once the most secret place in the sky, is now a place where the future is being made, and where the search for answers about our universe, our home planet, and our own abilities is only just beginning. People everywhere are now looking at the far side of the moon, not just with hope for the future, but with fresh questions about all that still remains unknown. The discoveries made so far have solved some old puzzles, but have also shown that many secrets are still hidden in its rocks, dust, and deep underground layers. The mystery of the far side is not just about what scientists do not know yet. It is also about how each new answer brings many more questions to explore. When you look at detailed maps of the moon's far side, it is easy to see the large, deep craters and rough, broken ground that stretch for hundreds or thousands of kilometers. Some craters are so old that their walls have fallen in and new craters have formed inside them, while others are fresh and bright, made by recent impacts. These marks are clear evidence that the moon has been struck by objects from space for billions of years. Still, there are areas where the number, shape, and pattern of craters do not fit what experts expect. Some have odd lines, double walls, or chains of holes going off in strange directions. Even now, specialists cannot say for sure when all the biggest craters and basins formed. In some places, layers of dust and rock have covered the oldest marks, making it hard to decide their age. Careful counting of smaller craters and looking at which mark covers which gives some ideas, but the oldest events go back so far that exact dates are still unknown. New ways to date rocks must be tried, and samples from deep inside the moon are needed to fill these gaps. The uneven ground of the far side also holds ridges, cracks, and sharp drops that have not been fully explained. Some of these look like scars made by waves of force from great impacts in the distant past, but others appear to be changes in the rock from heat and the slow stretching or shrinking of the surface. Some rise up for many kilometers and then end suddenly, with no clear start or finish. Scientists are also searching for what made the far side's surface so different from the side facing Earth. Most agree that the crust is thicker there, but they do not all agree about why. Some believe that an early giant impact changed the flow of hot rock inside the moon, keeping lava from breaking out and leaving the ground rough and old. Others think that the way Earth's gravity pulls on the moon may have changed how the crust cooled, but the exact answer is still a mystery. The story of the hidden metals deep under the surface is another puzzle that is not yet finished. The clues from radar, gravity, and magnetic maps are strong, yet until new missions bring up large samples from the far side, nobody can be certain. Is the metal from a giant space rock that crashed long ago, or is it from the moon's own core? Did the same thing happen on other planets, or only here? The answers to these questions could change what people think they know about the whole solar system. Other secrets still wait in the patterns of unusual lines, grooves, and marks that do not fit normal ideas about craters or flows. In some places, fields of small pits look perfectly lined up, as if shaped by forces under the ground instead of rocks from space. Other areas have faint shapes hidden by dust, seen only in special light or by computer. Many of these patterns have never been found anywhere else and do not match stories about impacts or lava. Even recent technology does not always give clear solutions. Spacecraft and robots can record only part of what happens. Cameras, sensors, and drills help, but each machine has limits. Sometimes a cloud of dust or a sharp rock breaks a tool. Sometimes the cold and darkness of the lunar night stop a lander from working before it finishes its project. Special robots are being planned to dig deeper and survive longer, but every new plan faces old challenges. Another big question is about the moon's history. People have learned that impacts, volcanoes, and slow changes inside the moon have all played a part in shaping the far side. but it is not certain how many impacts happened or how much lava really flowed under the old crust or how heat moved from deep inside out to the surface. Some areas seem never to have been touched by lava at all, while others have thin, hard layers that cover old basins like a shield. Studies of moonquakes show that the ground still moves in some places, hinting that the moon is not fully quiet. Every new signal about temperature, energy, or movement can change what is known about the shape of the inside. The far side's effect on Earth is now being looked at in new ways. Its weight, changing gravity, and movement connect to how the moon moves in the sky and how tides form on our planet. If the hidden metal areas are bigger or heavier than first thought, it could even change how the moon moves over thousands or millions of years. With every mission, people learn a little more about this link between our world and its nearest neighbor. Listening devices, telescopes, and radio tools planned for the far side are helping answer questions about space far beyond the moon. They are picking up signals from deep space, from distant explosions, and from stars that were born when the universe was very young. But even here, new mysteries appear. Some signals are stronger, weaker, or stranger than expected. Some scientists wonder if dust, rocks, or hidden shapes under the ground might change what is heard, or if totally new kinds of energy or waves are coming from far away. Life on the far side is another topic that brings questions. Most people believe there is no life on the moon now, no plants, animals, or tiny life forms. But scientists want to test if any signs remain from the very early days when the moon was still hot, or from objects that fell from space. Could rare chemicals or even tiny minerals give clues about ancient life on Earth or other planets? To know, teams must search and dig in new places, often deeper and farther than before. Future plans for the far side include building safe bases for people, deeper holes for samples, and wide telescopes. But each of these needs answers to problems that have not yet been solved. How deep is it safe to dig before hitting hidden metal or hard stone? Can robots clean dust off solar panels and sensors for many months? Can plants grow using the moon's soil, or will astronauts need to bring all their own food? Each solution will give lessons for later plans to explore Mars or the moons of giant planets. Working on the far side has also shown that science is always moving forward. What is thought true today might change tomorrow with new measurements. Sometimes missions that seem simple find surprises no one guessed. Each child or student who studies a new map or test result could one day be the person who answers one of these old mysteries. The knowledge about the moon grows in steps, shared and added to by people everywhere in the world. The moon's far side is now part of human stories almost as much as the side always seen in the night sky. People understand that there are questions still without easy answers, about how the face formed, about what is buried below, and about how it affects Earth and the solar system. These questions show how even with the best tools, cameras, and science, there are still things waiting to be found. Every mission brings a few answers but gives back more questions. That is what makes the search for understanding so exciting. If there were no mysteries left, there would be nothing left to learn. The far side teaches people that every discovery is just the start of a new story. The more is found, the more there is still to find. Scientists keep working to collect better samples, record clearer pictures, and plan smarter robots for the moon. They keep building new tools for listening, digging, and mapping. Teachers keep showing their students how to read real space data and spot new patterns. Teams across the world check and share each bit of information, wanting to be the first to find a new clue or make the next big step. The moon's far side stays quiet, with sharp shadows, cold nights, and long days under bright sunlight. It keeps its secrets in silent rocks, deep holes, and hidden lines nobody yet fully understands. But people are closer than ever to opening these mysteries. The story of the far side is not only about the past, it is about the future too, about what new eyes may find there, what new tools may record, and what new explorers, human or machine, may uncover. The greatest secret may be that the moon is still changing. It is not only a dead world of dust and craters. With every impact, every new robot, every flash of sunlight, the face of the far side changes a little. Even the rocks and metals below are moving, shaped by forces scientists are just starting to study. The more that is learned, the more it is clear that the moon is part of a living solar system and that the far side is a place full of possibilities. Long into the future, people will still look up at the moon and wonder what is hiding just out of sight. Writers will make stories, scientists will make plans, and children will make dreams. The mysteries of the far side will travel in books, in lessons, in photos, and in each mission that crosses the empty sky. Each new year will bring closer the answers to old questions and open the way for new ones. The journey to unlock the far side will go on as long as curiosity remains. As long as humans want to know what is hidden, as long as science keeps asking why, there will be a reason to study, dream, and explore. The moon's far side is a reminder that the universe is large, complex, and wonderful. Its secrets are waiting for anyone ready to search, to listen, and to keep open the door to learning. This is not the end of the moon's story. It is only another beginning, one that belongs to everyone.